In this video, we're going to wrap up our discussion on occlusion culling with a look at creating some target occlusion areas that are supposed to be in place to handle things that are animated, things that are not static in your scene. Now, right now, the only thing we have that's not static is our character. So we're going to bring the ball to life first and then talk about some other interesting things that will pop up.
Right, and basically what we need to do is make our ball not be static anymore. And while I'm at it, I'm actually going to turn all the props to not be static. So basically we're going to have all of our props now are technically non-static or animatable.
Okay.
So the one that we're going to focus on though is going to be our sphere. We're not actually going to put any animations on our cylinders. We'll leave those as they are. So what I'm going to do is I'm going to focus up on the ball and get my camera in position. What we're going to do is we're going to animate this guy going from here to here and then back and just back and forth.
Okay. So
it's a fairly simple process. We come down to our project window. We're going to create another folder. This folder will be called _animations. Hopefully I spell it correctly. Hit enter and select our ball. Go to window and we have an animation panel. We can open it up. It brings up our animation. Now what I want to do is, because we have our ball selected, we have our transform properties. Select on any one of these. The one we're going to be editing is position Z, because we want to go and move the ball along the Z axis. So we'll hit this little drop down, hit add curves. It's going to ask us to create an animation file. We're going to open up our animations folder that we just created, and we'll rename this to be ball.anim. So that will be our animation file. Now if we open up our animations folder, we can see our ball file that we just created. We want to set our wrap mode before we start adding keys, because what will happen is if you add your keys, do all kinds of crazy animation, then come back in here and change your wrap mode, what I've found is it will delete all your keys and we end up having to do it again. So we'll go ahead, we'll set our wrap mode to ping pong, because basically we just want to animate one additional key and have it cycle back and forth between those two keys. So with the animation set to ping pong, we select our ball again. We can see it's got a couple of initial keys. I'm going to click on the timeline, take our current frame, set it to 0. I'm also going to use the mouse wheel to pan back out so I can see more of the timeline. So here, because I want to animate position Z, I'm going to click inside of its property setting, and I'm going to take the number, which is 3.496, and I'm going to copy that. I don't need the sign because currently it's at -3.496 on the Z axis, and I want it to cross the 0 of the Z, which is right down the middle of the hallway, and translate to the positive side by the same amount. So with that number there, I'm going to take our time slider, set it at the 5-second mark right here, and then I'm going to go ahead and add a key at that point. The key is going to remember its initial setting, so it's a straight line. So what I'm going to do is go ahead and click in here, paste out our number, and our ball pops over. If I actually take our time slider and scroll back and forth, we can see that it moves from one position to the other. Now what I also want to do is select this key, right click, and make it flat, and I want to make this key and make it flat. So what we've got is an ease out and ease in effect on our animation curve. So what it does is, in effect, it takes a little bit of time for the ball to get rolling, then it starts speeding up, and about halfway through it's at its max velocity, and then it starts to slow down as it gets to the end of the animation. And with it being ping-ponged, what will happen is if I scroll out, you can see that it's going to continue this animation on and on and on. So that is all we need to do to get the animation working. I can go ahead and hit stop, leave the camera where we are, go ahead and hit play, and we should see the ball animate, but we don't. Why not? So our sphere is set animation. Oh, our animation is missing, so I'm going to set our size down to 1. Set our animation to be ball. Hit enter. Select our animation up here to be ball. And the reason why this happened is I was playing with the animation earlier, and the animation on the ball wasn't removed. So when I added a new animation, it incremented my animation size. So another way I could do it is just to come in here, remove the entire component altogether, take our ball animation, drag and drop it onto our ball, and we have our animation again. So now when I hit play, our ball should actually move. So there it goes, and it's moving back and forth. And if I actually deselect the ball, and because it is a solid red sphere, it actually looks like it's rolling. So it's an illusion. It's actually not rolling. It's just sliding back and forth.
Now, yeah, I was just going to say, now with her, you can run on around there, and you'll be able to see it from inside our actual game window.
Well, no, we won't, because...
Hang on. That's what I was going to get at. Hang on. Run back over there. Got a nice little shadow.
It's like, there's our ball.
Yep.
Oh, there it is.
Yeah.
So
that's what I meant by if you run in there, you'll be able to see it.
We'll be able to see it, but because we move out into the hallway, we won't.
Yep. Because the renderer is simply turned off based on where your camera is at the moment. We've not rebaked anything. The data still exists from the last video. And because of that, and because of where the camera is right now, down in the scene view, that's why I wanted you to go down in the scene view.
Right.
Unless you run in there, it's off. But if you run in there, you can see it, and you can see that it's moving.
But let me turn off the target and the view. But as far as our occlusion culling is baked out, and it, as far as it's concerned, when we're in this area, this ball is still sitting right here in the right-hand corner. So it doesn't know it's moving.
Because the data's baked out. That's why we bake it. It's not dynamically calculating that. It's just dynamically, basically calculating based off the data from the cell that the camera is currently in. Can we see that ball with where it was originally baked out, that geometry?
Right, which is the whole point of why we have target areas in addition to handle when the ball is actually in motion.
But running into the room, you can see the ball.
Yep. So, and I can actually get right to the doorway, right where you couldn't see it.
Yeah, right now you're running with the higher or lower cell size.
And it just matters on where my camera's positioned. So if I put position here, it disappears. If I move it over here where it would normally appear, you can see it.
Exactly.
And if I go into the room, it'll disappear because of frustum culling. But if I spin around, there it is.
Now it's going to stay. So now let's see what happens if we just do another bake. We'll clear our data out.
You want to run it without any data?
Without any what?
Any data whatsoever? Show them what happens?
Sure.
Because we've cleared out our data, there's our ball.
Nothing is going to disappear.
Correct.
But now let's show them what happens when we do another bake, but we have not set up any target volumes.
Oh, now that it's animated. I was trying to think.
Now that it is no longer static, along with our...
we'll go ahead and set it back to preview. But now this is no longer static and just bake out. So it's only going to bake out the things that are still static.
And we have nothing set up whatsoever in the scene that will designate a target area. And because of that, it's just going to stay visible at all times, while we will see the left and right walls in that room with the ball vanish, as you just saw it take place there.
Right, so if I go ahead and I click on each of our custom occlusion areas, each one of them is a target volume turned off.
Yeah, that's right, has it turned off. So because of that, we simply do not see it. So, but now the sphere will stay visible along with our pylons at all times.
Right, because there are no target areas being calculated.
But man, it sure would be nice if that sphere would disappear when it went behind something that prevented us from seeing it.
Okay, well, to do that, we need to create a target volume.
Sounds good.
All right, so let's pause this. I'm going to go ahead and go into my occlusion areas, go back to object, because this is where we go if we want to click another one. We're going to create a new one. Now this one is going to be a target volume, so we're going to turn off is view volume, and we're just going to use it as a target volume. So we'll leave the resolution at medium for now. And we'll take our occlusion area, and I'm going to move it into the parent of the other one, rename it F2, or just click to rename it, and I'm going to call this occlusion area ball. I'm going to then size this. Let's
just go ahead and frame up on the ball and move it to view, and then maybe it'll just make it easier to size it all up.
Or I can hit Control F because my camera is already here.
Okay.
So,
yeah, you can there. I was just thinking center it up on the ball just so you can size it up around the ball, but you can. That's fine.
oh, I see what you're saying. You want to do this. Control Shift F will actually move whatever's currently selected to be in the center of your view.
Right.
So it's a handy little trick.
So if you actually center up on the ball or frame up on the ball, then you could basically.
Yep. And then go ahead and hit the ball occlusion, Control F. Now I understand what you're saying. So now it's centered on the ball. Now, again, we can dial in the numbers by hand if you want, or we can click on the little handles. Let's go ahead and do rotation to get those out so I can size up our view area. Kind of like, oops.
Yeah.
I hit the wrong one. So resize it. Zoom out. There we go. Get that one. That way I can free up my handles, make it a little bit easier to grab hold of them. So now I can bring this down. And I'm just moving the camera around to make it easier to grab hold of these little manipulators. Bring this out. Set this one all the way to this side of the room because the ball actually is moving back and forth. What you want to do when you're creating this is create a volume that contains the ball through its entire range of motion. So that's actually a bit too far out on this side, so let's bring this one in. So now we've got a target volume that contains the entire range of motion that our character has. Or not our character, but our ball has. So if I were to go ahead and go back and clear all of our data, just so we have none, just to make sure. Come back to bake.
Before we hit bake, let's jump back over to object for just a moment, the object tab.
Okay.
And let's talk for just a second about the target resolution.
All right.
All right. Well, with bake, we saw the view cell size that we could adjust. But when you're dealing with a target volume, it's a little different. We have a setting down here that we can use to control the resolution as opposed to just being able to specify an exact view size. So if you drop that down, we can see that we have things like low, medium, high, very high, and extremely high. And as Lee is clicking on those, you can see it's very tough to see, but if those of you, yeah, that's a good idea. That'll make it, should be a little bit easier, maybe.
Well, it's the draw stuff again.
But that's okay. Let it draw it in a funky area, but we can still see it, though.
I was just wondering what would happen if I switched over to the wireframe. That would make it easier.
It's not too bad. Okay, so jump between a few of the settings.
All right, so if I go from low to medium,
denser,
high,
more dense,
very high,
crazy dense.
Mm-hmm. And just like anything else, the higher you go with these, the longer time it's going to take to bake this out.
And the more data that needs to be stored.
Mm-hmm. But you do get more accurate results. So if we go down to low, and we start off with low, we'll test it out and you can see how this is going to calculate out. So we'll start off with low and then bake that out, and then we'll see how it looks, and then we'll dial up the setting a notch or two and see what difference that may or may not make. So as you can see, everything's still low, so it's still baking out fairly fast, but we got an interesting effect here. Already we can see something. So if I hit play,
where's our character?
Yeah, our character, hold on, why is our character, let's go back over here. Our character is doing some really weird stuff.
And this is, in my opinion, this is pretty cool here. If you go back into our scene view and make sure target's turned on, maybe even try going to a top view.
You want to do top? All right.
And then turning on the, yeah. All right, now deselect that. And
Oops.
let's see.
I managed to hit the floor. All right.
Looking for everything. Go ahead and turn, visualization back on. There we go. Good. All right. So There's our sphere going back and forth, currently visible.
Well,
Now,
that's because I've got it selected.
our character does some weird, interesting stuff.
So as I move around, our character will pop in, pop out.
Interesting. Why did we get full black on the top?
Because I'm in overdraw. That's alpha.
Oh, because you're in
It's still
wireframe still.
There
we go.
Wireframe. There we go.
So
Right.
I just wanted everybody to be able to see it a lot better there, and that's what I was looking for. So now, with the resolution that Lee is using, which is low, watch the ball. He does disappear, but only when he gets to the extreme end of the volume that Lee set up. the
Right,
target
and he's
volume.
disappearing right around here. So, let's see, if you watch him when he clears the door, which is right about here, he should disappear roughly when he gets, below this part of the room. But he's not. He keeps going and going and going until he passes outside of this range. And
Because those particular, if I reach
Go
all
ahead.
the way over here and grab the mouse, because these guys right here can be seen from these cells over here. I mean, so the cells can see straight through. So it has to get, this sphere has to get past these cells down here before it goes invisible. Watch, invisible, and then back.
Right.
As soon as any part of it comes back into a cell that can be seen, it will be visible.
Right, and well, as you saw when we were running this, there are some other artifacts. We're going to address these shortly, but what we're going to show next is how we can tighten up this and get a more accurate representation.
So
of
watch
when that ball
this.
is-
Right now,
Mhm.
take a look at this. Where your camera's at, you see the cells, the visible cells, the blue ones.
Mhm.
You can see all the way down to where our sphere is at the moment. Now watch the sphere. So the sphere is moving back up, out. Now it's gone for a lot longer up at the top because, yeah, that's the farthest we can see. Now look, as Lee's adjusting this around, you can watch how it's grown a little bit further, and now it's just a little flip of the ball going outside and becoming what's considered occluded for a dynamic object there. Ooh, that was a very nice one. Turned where very little of that's visible, right there. So right there, right, back up. Look, yeah, right there. So now look, it's staying gone for a long time. Even we are staying gone for a long time. Awesome. So,
Well, if you look, all it's showing is this part. It's not even showing anything down here.
yep. So now let's just adjust that back around. As you come back in, as soon as you go bloop, right back in there, now we've
Yep.
got a character.
Yep.
Now
So-
watch this. If you keep adjusting it, if you find the right angle and get some view where you might have some of the pylons being picked up, this requires a little bit of running around and adjusting, and just maybe, and maybe not with this resolution. Just
I'll have to come back this way.
There you go, and you can see it too.
So if I switch over and
To
go
RGB and rotate around.
bring it back in.
There's the one.
So as you play around with it, you can get, now we've got two.
Very interesting results.
There we go. Now they're all there.
Yep. Now, let's take a look at how we can help solve some of this problem here if we wanted to.
All right. Well, what's going on is basically, if you remember, we set all of our props to be non-static. So we've unchecked static from all of these, which means as far as the occlusion culling system is concerned, these things can move. So the only way they can be brought back is to actually put them inside of a target volume, or when they've been
Or when wherever the camera is positioned can see all the way down to where we've set up a target volume. And that's why when Lee positions it just right so we can see down the hall and into part of that, then this whole area that we're able to use to see the cells down there then extend with cells our way, just saying, hey, this is the area in which you can see.
Right, which is definitely not a very good way of allowing stuff to show up. So we have a couple of different solutions that you can use. If you want these to show back up because they're not moving, the simplest way is to set them static again. That'll bring them back. But let's say there is a potential for these things to move. Let's say some sort of explosion can send them flying, so they have to move. So one way that you can do it is we can actually take our room. Let me turn off visualization so we can see what's going on.
A nice way to do this might be just to stop play and start with our character. Let's do it with her first.
Oh, you want to fix her first?
We can fix her first,
All
and
right.
then we can look at those guys.
All right. Well, with dealing with our character is a different set of problems. Our character has the ability to move.
Different set, very related, though.
True.
If we're stipulating that those things could be, those pylons could be knocked and blown around.
Right.
So, very similar, actually.
Right. Our character can move. Now, the interesting problem with our character is our character, to be visible all the time, has to be calculated in some sort of target area, target occlusion area. So because she can move, we either have to set up every area that she can be in to calculate target areas.
Which is one of the reasons why you have the ability, when you put in an occlusion volume, of saying it's both view and target.
Correct. But that may be very inefficient because let's say you have large expanses or large areas that are completely made up of static objects, and the only thing that is ever going to be animated through there is going to be your character. If that's the case, then you're doing a lot of calculations for nothing. So one of the ways that we can get around this is actually to attach a target area that travels with her. So what I'm going to do is
just as a regular component to the game object.
So we're going to close everything up and clean things up a bit. I'm going to close down this panel. I'm going to make sure our character is selected. I'm going to close up all of the scripts that I have on her just so we can see what's going on. And then I'm going to do component, rendering, occlusion area. Hit add. Now we have an occlusion area that is parented in or is added as a component to our character. It comes with all the stuff that you're used to seeing, which is size and your centering, whether or not it's a view volume or a target volume. We don't want it to be a view volume. We do want it to be a target volume, and we have our target resolution that we can dial in to get the results that we need. So I'm going to go ahead and size up our box, and I'm going to offset it by
and the
1.
Interesting thing to keep in mind here is you don't have to be too particular about the size of this, because we fall back to the it's all one piece of geometry for her, and if part of the geometry is in a cell that's visible, then she's going to be visible. So obviously at one point or another we're pretty much always looking at some part of the character. So I'm just saying we don't have to be too particular. That's all.
Exactly.
Okay.
So I'm just making sure that it's large enough that it covers all ranges of motion that she could possibly go through.
Yeah,
So-
that just so that people don't think that if her arm goes outside the box, she's going to vanish. But
Right.
if you had gloves on her hands that really were different objects that were just parented into a hierarchy, then they could disappear or do weird stuff. I would just say do weird stuff instead of disappearing, because you're still going to run into the situation where the engine can still see over there because of the view volume, and it'll extend the target area as well, so it'll actually still stay visible. Anyways, so just by adding that around, let's see if that fixes our flickering problem if we were to clear and rebake our data.
Alright, so let's clear it, make it go all the way, and then come back to bake, switch us back to preview. View size, cell size is going to be 1, go ahead and bake. And as you can see, the more stuff we add, the slower this gets. It's still not painfully slow because we have an extremely simple level. So it's just a matter of a few seconds. But also, we've added more stuff, and as you can see, our sizes are continuing to creep up. So if I go ahead and hit play now, our
Well, there
character's
she
here.
is. Before, when we hit play, she just vanished and then kind of flicked in and out.
Bring the camera in a little bit. So if I go back to overdraw, let's go back to top. So Now what you see is a little bit different than what we had before. We now have cells that are showing up. But if you look, as we move, our calculations are adjusting to take into consideration that we have a target area that's moving around. So it's updating and ensuring that everything shows up here. For the most part, all of a sudden our cylinders came back. And it's like, oh wow, that's great. So, but once we pass out of here, if I come back to, let's do RGB, back into perspective, turn things around. They're still visible. Helps if I do visualize. So as I'm in this room, they're still there.
Yeah, now back off, back away.
Trying to see if I can get them to disappear.
But you just have you've got, well, there you go for sure.
Right.
The cells and all, again.
There we go. But because, you remember, the cylinders are not static objects, so they're not being handled by the...
That's right.
They're not being handled by the occlusion culling. So technically, they should never disappear.
Right.
If everything was working the way it's supposed to. But they still disappear.
That's right.
So that's what I was trying to show. I just had to find the right camera angle to show that up. So now we've got that. Let's go ahead and pause.
It's because the bottom line is they were not put into a target volume area. And you really want to use a target occlusion volume area if you have objects that are animated. They need to be within one somehow. Otherwise, we're just relying on almost unpredictable results of something that is in a target area that's being seen just right by the camera at the right angle to then kind of lend the visibility over to another object that's not static but is not in one of these custom target volume areas that we've created for it to become visible.
Right.
So you really need to handle those objects like we've handled the character here.
Right. So depending on what you want to look at is look at the object, how it's moving, and decide what is the appropriate way to deal with it. If it's an object like your character or something that's going to get blown up and thrown around your scene, then you want to have a target area that is parented into that object so it follows it wherever it goes. If you have a whole bunch of blocks and they might get knocked around and they're animated falling or whatever, but they stay within a certain area, say a room, and they never leave that room, then you could, instead of parenting a whole bunch of target areas to each one of those objects, you could set up the target area for that entire room.
Right.
So then everything inside of that room will then be tracked and taken care of.
Exactly. So I think that pretty much covers everything. I mean, we looked at the Object tab, we've looked at the Bake tab, and the Visualization tab is what needs to be activated for you to be able to visualize in your scene view what is and is not being drawn. So go ahead and click on Visualization real quick, making sure there's nothing else that I think that pretty much covers everything.
Mm-hmm.
Anything else you want to add in? Because this is it. This is it for this series. I mean, we'll come back in a conclusion video next, but...
No, that actually shows everything on how to deal with occluders, why you want to use occlusion culling to begin with, where it's effective, where it's not so effective.
All the parameters.
Mm-hmm. Sweet.
Okay, well, ladies and gentlemen, with that concludes this video. Thanks a lot.